Let's examine the difference between an equipment grounding conductor and an equipment bonding jumper, and how the National Electrical Code, or NEC, addresses their installation. Specifically, we will analyze the scenario involving two panels situated less than 6 feet apart, where one panel feeds the other, with all circuit conductors running in a short conduit except for the equipment grounding conductor, which is external to the conduit. The question revolves around whether this configuration complies with the NEC, especially considering that Section 250.134b generally requires the equipment grounding conductor to be within the same raceway or cable as the circuit conductors, while Section 250.102e might allow an equipment bonding jumper to be run separately. To begin, it's essential to define the terms equipment grounding conductor and equipment bonding jumper. An equipment grounding conductor provides a low impedance path for fault current to return to the source. This path is crucial for the operation of overcurrent protective devices like circuit breakers or fuses, which must quickly trip or blow in the event of a ground fault. The equipment grounding conductor ensures that the metal parts of electrical equipment, such as enclosures and raceways, are at ground potential, minimizing the risk of electric shock. An equipment bonding jumper, on the other hand, connects metal parts of the electrical system to ensure electrical continuity and conductivity. Its purpose is to create a low impedance path between these metal parts, so they are at the same electrical potential. Bonding jumpers are used to bond enclosures, metal raceways, and other non-current carrying metal parts of the electrical system. Now, let's analyze the relevant NEC sections. Section 250.134b typically mandates that the equipment grounding conductor be installed within the same raceway, cable, or otherwise run with the circuit conductors it serves. This requirement aims to minimize impedance and ensure that the grounding path has sufficient capacity to safely carry fault current. However, Section 250.102e provides specific allowances for equipment bonding jumpers. This section permits equipment bonding jumpers to be installed outside of a raceway under certain conditions. To determine if the contractor's installation is code compliant, we must ascertain whether the conductor in question truly functions as an equipment bonding jumper as opposed to an equipment grounding conductor. If the conductor serves to bond the two panels together, ensuring electrical continuity between their metal enclosures, and meets the requirements of 250.102e, it may be permissible to run it outside the conduit. Several factors influence whether a conductor is classified as an equipment grounding conductor or an equipment bonding jumper. These factors include the conductor's size, its purpose, and its termination points. The NEC provides tables such as Table 250.102 C1, which specifies the minimum size requirements for equipment bonding jumpers based on the size of the ungrounded circuit conductors. If the conductor in question meets the size requirements for an equipment bonding jumper and is properly connected to bond the metal enclosures of the two panels, it might be considered compliant with 250.102e, even if it runs outside the conduit. However, if the conductor is intended to serve as the primary equipment grounding path for the circuits within the panels, it should be installed within the conduit alongside the circuit conductors as required by 250.134b. Consider the specific application. Is the conductor primarily intended to bond the two panels together, ensuring that their metal enclosures are at the same electrical potential? Or is it intended to provide a low impedance path for fault current to return to the source? The answer will determine whether it should be classified as an equipment bonding jumper or an equipment grounding conductor. Now, let's consider the question regarding Exhibit 250.43 on page 223 of the 2005 NEC Handbook. This exhibit likely illustrates a specific scenario involving equipment grounding and bonding. Without the specific details of the exhibit, it is difficult to provide a definitive answer. However, the general principle remains the same. If a green wire is installed inside a flexible metal conduit, its function as an equipment grounding conductor or bonding jumper depends on its purpose and connections. If the green wire is intended to provide a low impedance path for fault current and is connected to the equipment grounding terminals within the enclosure, it functions as an equipment grounding conductor. In this case, it should comply with the requirements of 250.134b and be sized according to Table 250.122. On the other hand, if the green wire is intended to bond the flexible metal conduit to the equipment enclosure, ensuring electrical continuity, it functions as an equipment bonding jumper. In this case, it should comply with the requirements of 250.102e and be sized according to Table 250.102. C1. The NEC also provides specific rules for the use of flexible metal conduit in grounding and bonding applications. Section 250.118 specifies the conditions under which flexible metal conduit can be used as an equipment grounding conductor. Generally, flexible metal conduit is permitted to be used as an equipment grounding conductor if it meets certain requirements, such as being listed and having fittings that are identified for grounding. If the flexible metal conduit does not meet these requirements, a separate equipment grounding conductor must be installed, either inside or outside the conduit, depending on whether it functions as an equipment grounding conductor or an equipment bonding jumper. It is always crucial to consult the latest edition of the NEC and any applicable local codes to ensure compliance. The NEC is updated regularly to reflect changes in technology and industry best practices. In addition, it is advisable to consult with a qualified electrical inspector or engineer to obtain a professional opinion on specific installations. The electrical inspector will evaluate the installation based on the applicable codes and standards and can provide guidance on how to ensure compliance. Furthermore, it is important to maintain accurate documentation of all electrical work, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be helpful in resolving any questions or disputes that may arise in the future. In summary, the key to determining whether the contractor's installation is code compliant lies in understanding the distinction between equipment grounding conductors and equipment bonding jumpers, and in ensuring that the conductor in question is properly sized, connected, and installed in accordance with the NEC. If the conductor serves as an equipment bonding jumper and meets the requirements of 250.102e, it may be permissible to run it outside the conduit. However, if it serves as the primary equipment grounding path for the circuits within the panels, it should be installed within the conduit alongside the circuit conductors, as required by 250.134b. Finally, always consult the latest edition of the NEC and with qualified professionals to ensure compliance with all applicable codes and standards. Let us delve deeper into the specific National Electrical Code sections mentioned, 250.134b and 250.102e, to provide a more granular understanding of their implications. NEC Section 250.134b, titled Equipment Fastened to Metal Surfaces, outlines the requirements for grounding equipment that is fastened to metal surfaces, such as metal enclosures or raceways. This section generally mandates that the equipment grounding conductor be installed in the same raceway, cable, or otherwise run with the circuit conductors supplying the equipment. The rationale behind this requirement is to minimize impedance and ensure a low impedance path for fault current to return to the source. By running the equipment grounding conductor alongside the circuit conductors, the inductive reactance is reduced, resulting in a faster and more effective clearing of ground faults. There are some exceptions to this general rule, as outlined in 250.130. These exceptions typically involve situations where it is impractical or impossible to run the equipment grounding conductor with the circuit conductors. However, in the scenario described, where the two panels are located close together and connected by a short conduit, it should generally be feasible to comply with the requirements of 250.134b by running the equipment grounding conductor within the conduit. NEC Section 250.102e, titled Equipment Bonding Jumpers, addresses the requirements for equipment bonding jumpers, which are used to connect metal parts of the electrical system to ensure electrical continuity and conductivity. This section provides specific allowances for equipment bonding jumpers to be installed outside of a raceway under certain conditions. One common application of 250.102e is in bonding metal enclosures that are not directly connected to a raceway. For example, If two metal enclosures are located close together but are not connected by a conduit, an equipment bonding jumper can be used to connect them, ensuring that they are at the same electrical potential. In order to comply with 250.102e, the equipment bonding jumper must be properly sized and connected in accordance with the NEC. The size of the bonding jumper is typically determined based on the size of the ungrounded circuit conductors, as specified in Table 250.102. Sheet 1. The bonding jumper must also be securely connected to the metal enclosures using approved methods, such as bonding bushings or bonding locknuts. In the scenario described, the contractor is arguing that the conductor running outside the conduit is an equipment bonding jumper and is therefore permitted by 250.102e. To evaluate this claim, it is necessary to determine whether the conductor meets the requirements of an equipment bonding jumper and whether it is properly sized and connected. If the conductor is primarily intended to bond the two panels together and meets the requirements of 250.102e, it may be permissible to run it outside the conduit. However, if the conductor is intended to serve as the primary equipment grounding path for the circuits within the panels, it should be installed within the conduit alongside the circuit conductors, as required by 250.134b. Furthermore, it is important to consider the overall grounding and bonding system. The NEC emphasizes the importance of creating a low impedance path for fault current to return to the source. This path should be continuous and uninterrupted from the point of the fault to the source of the electrical supply. If the conductor running outside the conduit compromises the integrity of the grounding and bonding system, it may not be code compliant, even if it technically meets the requirements of 250.102e. In addition to these specific NEC sections, it is also important to consider other relevant provisions of the code, such as those relating to the installation of raceways, conductors, and grounding electrodes. These provisions can provide further guidance on how to ensure a safe and code-compliant electrical installation. For example, Section 300.3b requires that all conductors of the same circuit, including the equipment grounding conductor, be installed in the same raceway or cable unless specifically permitted otherwise. This requirement is intended to minimize impedance and ensure a low impedance path for fault current. Ultimately, the determination of whether the contractor's installation is code compliant will depend on a careful evaluation of all the relevant factors, including the purpose of the conductor, its size, its connections, and its impact on the overall grounding and bonding system. Consulting with a qualified electrical inspector or engineer is highly recommended to obtain a professional opinion and ensure compliance with all applicable codes and standards. Let us further investigate the parameters that define if the existing green wire inside the flexible metal conduit is still a bonding jumper or an equipment grounding conductor. The key lies in the intended function and the actual connection of the wire. Firstly, if the green wire inside the flexible metal conduit is connected to the equipment grounding terminal within an enclosure and is intended to provide a low impedance path for fault current, it functions as an equipment grounding conductor. In this scenario, it must adhere to the sizing requirements outlined in NEC Table 250.122, which dictates the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. Also, the flexible metal conduit itself must meet the requirements of 250.118 to be used as an equipment grounding conductor. It needs to be listed and have fittings identified for grounding purposes. Secondly, if the green wire's primary purpose is to bond the flexible metal conduit to the equipment enclosure, thereby ensuring electrical continuity between them, it is classified as an equipment bonding jumper. In this instance, it must comply with the stipulations of 250.102 C1, which provides guidelines for the sizing of equipment bonding jumpers based on the size of the ungrounded circuit conductors. It is vital to note that the function of the green wire is not solely determined by its color but rather by its application and connections within the electrical system. The NEC mandates the use of green or green with yellow stripe insulation for equipment grounding conductors and bonding jumpers, but this color coding serves primarily for identification purposes. To further elaborate, consider a scenario width, the flexible metal conduit serves as the primary grounding path. If the conduit is deemed inadequate for grounding due to its construction or the fittings used, a supplementary equipment grounding conductor is required. This conductor, typically a green wire, would then function as an equipment grounding conductor and would need to comply with the requirements of 250.122. Conversely, if the flexible metal conduit is properly listed and fitted for grounding, a green wire installed within it could serve as a bonding jumper, ensuring electrical continuity between the conduit and the equipment enclosure. In such a case, the sizing requirements of 250.102 Seat 1 would apply. The distinction between an equipment grounding conductor and an equipment bonding jumper is paramount for ensuring electrical safety and code compliance. Improperly sized or connected grounding conductors or bonding jumpers can compromise the integrity of the grounding system, increasing the risk of electrical shock and fire hazards. It is also important to consider the length of the flexible metal conduit. The NEC imposes limitations on the length of flexible metal conduit used for grounding purposes, primarily due to the increased impedance associated with longer lengths. If the flexible metal conduit exceeds these length limitations, a separate equipment grounding conductor is required, regardless of whether the conduit itself is listed for grounding. In conclusion, the determination of whether the green wire inside the flexible metal conduit is an equipment grounding conductor or a bonding jumper hinges on its intended function, its connections, and the characteristics of the flexible metal conduit itself. Adherence to the relevant NEC sections and consultation with a qualified electrical professional are essential for ensuring a safe and compliant electrical installation.